In question number 7, a liquid of density rho is filled in a cylindrical vessel whose base radius is r. A wooden cylinder of height h, base radius r by 2 and density rho by 2 is floating in the liquid. Minimum work to be done by external agent in completely immersing the cylinder into liquid is n times pi r square rho g h square divided by 128. Then find the value of n. So in this question, at t equal to 0, if I balance the buoyancy force with the gravitational force, then we see this value comes out to be h by 2, which is already given in the question. Now, if I displace the wooden cylinder vertically downward by a distance x, suppose I am moving in this way, I have displaced it by a distance x, so it is displaced by a distance x, then the liquid rises here by a distance y. So this will rise the level by a distance y. So at that moment, then the change in buoyancy can be written as density of liquid, that is rho, into volume. Volume would be pi r square by 4, that is the area, into change height of liquid displaced, that is x plus y. So this is the mass of liquid displaced into g, and that is equal to the value of F for minimum work done. So if I write the minimum work done, then W can be written as F into dx limit 0 to x. Now I have to find out the value of x in terms of h. Now the volume displaced of the liquid due to insertion of wooden cylinder is used up in rising the level of liquid. So I can write pi r square by 4 into x, that is the volume displaced of liquid, and that is equal to the rise in the level of liquid. So that is pi r square minus pi r square by 4, so that is 3 by 4 pi r square into y. So if I solve this, the value of y comes out to be x by 3. Now for complete immersing of the cylinder, the value of x plus y must be equal to h by 2. So if I substitute the value of y here, then 4x by 3 is equal to h by 2, or the value of x comes out to be 3h by 8. So the limit of integration is equal to 3h by 8. So if I substitute the data, so this comes out to be rho into g into pi r square by 4 into the value of x plus y is 4x by 3 into dx 0 to 3h by 8. So it comes out to be 3 by 128 into pi r square rho g h square. So on comparison, the value of n comes out to be 3. So the correct answer for question number 7 is 3. Let's move to question number 8. In question number 8, two tuning forks, one of frequency 304 Hz, are sounded together. Intensity of sound heard at t equal to 0 is maximum, equal to I0. At t equal to 1 by 3 second, intensity of sound is equal to I0 by n. Find the value of n. And it is given intensity due to each tuning fork is same. So we know that, so if the disturbance due to first sounding wave is A sine omega 1 t, and the disturbance due to second tuning fork is A sine omega 2 t, as the intensity are same, then I can say that their resultant y1 plus y2 can be written as 2A sine omega 1 plus omega 2 by 2 into t into cos omega 1 minus omega 2 by 2 into t. So if I substitute the value of omega 1, that is 2 pi into 300, and omega 2, that is 2 pi into 304. So it will come out to be 2a into cos of 2 pi into 2t, that is 4 pi t, into sine of 2 pi into 302 t. So if I see this, this is the behaving like an amplitude at that instant, which is variable. So we know that intensity is proportional to amplitude square. So for the first case, when the intensity is, so I can write intensity I dash by I naught, that is the maximum intensity, is equal to the amplitude, here it is 2a cos 4 pi t, its square is 4a square into cos square 4 pi t divided by the amplitude corresponding to maximum intensity is 2a square, that is 4a square. So it comes out to be cos square 4 pi t. Now I have to find out the value of I dash at t equal to 1 by 3 second. So at t equal to 1 by 3 second, it can be written as cos square 4 pi by 3, and the value of cos square 4 pi by 3 comes out to be 1 by 4. So from here the value of I dash comes out to be I naught by 4. So if I compare, the value of n comes out to be 4. So the correct answer for question number 8 is 4. Let's move to question number 9. In question number 9, an inductor of inductance L and two capacitors A and B, each of capacitance C, are connected in the circuit as shown in the figure. Initially capacitor A has no charge and capacitor B has charge CV0. At t equal to 0, switch S is closed. Then we have to check the validity of given statements. So let at any time t, the charge on the capacitor B is Q, then the charge on the plate of this capacitor is CV0 minus Q. At that instant let current through the inductor is I. Suppose I am assuming that the current is increasing, then the polarity of the inductor coil will be like this, plus is here and minus is here. So if I write the equation, L di by dt, this is equal to Q by C minus of CV0 minus Q by C. So if I solve this further, this is equal to 2Q minus CV0 by C, and this is equal to L di by dt. So if I check option A, charge on each capacitor is same when current in the circuit is maximum. So at the instant of maximum current, di by dt must be equal to 0. So at that instant we can see that Q is equal to CV0 by 2. So the charge on this capacitor is CV0 by 2 and the charge on capacitor A is also CV0 by 2. So option A is correct. Let's first of all check the validity of option D. Total electrical energy stored in capacitors varies from 1 by 4 CV0 square to 1 by 2 CV0 square during the cycle. So at t equal to 0, as I see, half CV0 square is the energy stored in the capacitor B. So at the instant of maximum current in the circuit, if I check what is the final energy stored, electrical energy, so this is equal to half into Q square by C. So Q square is CV0 by 2 whole square by C into 2, as the charge on both the capacitor is same at that instant. So this comes out to be 1 by 4 CV0 square. So option D is also correct. So let's check the validity of option B and C. So di by dt from here can be written as this divided by LC. So if I solve this further, it can be written as d square q by dt square minus 2 by LC into q plus V0 by L is equal to 0. The solution of this differential equation is q is equal to CV0 by 2 into 1 plus cos omega into t, where the value of omega is equal to under root of 2 by LC. And if I substitute the value here, this is equal to under root of pi square into 10 raised to the power 4, which comes out to be 100 pi. So on further solving, it can be written as CV0 value is 100. So 100 by 2, that is 50 millicoulomb into 1 plus cos into 100 pi t. So option B is correct and C is wrong. So the correct answer for question number 9 are option A, B and C. Let's move to question number 10. In question number 10, a swimmer crosses a river from point P and swims perpendicularly to the bank and reach point R in 20 minutes. If the swimmer heads at an angle alpha to the line PQ, he reaches opposite end after 25 minutes. Then we have to check the validity of given statements. In the first condition, as the swimmer moves in this direction, let the velocity of swimmer with respect to river is VSR. So I can say that VSR into time taken is 20 minutes, that is equal to 1000. And let the velocity of river in this direction is VR with respect to ground, then we can say that VR into 20 must be equal to 600. So if I divide these two, then from here VR divided by VSR is equal to 0.6. In the second condition, when the swimmer heads at an angle alpha to the line PQ, let the velocity of swimmer with respect to river is in this direction. Then the component of this velocity in this direction is VSR cos alpha, and the component in this direction is VSR sin alpha. So if the swimmer reaches to the exactly to the opposite end, then it means that VSR sin alpha must be equal to the velocity of river. So from here sin alpha comes out to be VR upon VSR, and from this equation this is equal to 0.6 or 3 by 5. So from here the value of alpha comes out to be 37 degree and cos alpha comes out to be 4 by 5. So let's check the options. In option A, speed of swimmer in still water is 3 km per hour. So from this equation we can find out the speed of swimmer with respect to river. So time is given in 20 minutes, so that can be written as 1 by 3 hour, and that is 1000 meter or 1 kilometer. So from here the velocity of swimmer with respect to river comes out to be 3 km per hour. So option A is correct. In option B, the speed of river is this much. So from this equation I can find out the speed of river. The speed of river is equal to 0.6 times 3, so it comes out to be 1.8 km per hour. So option B is also correct. I have already found out option C. So option C is correct and option D is wrong. So the correct answer for question number 10 are option A, B and C. Let's move to question number 11. In question number 11, for the system shown in figure, if image of point object coincides with itself, then value of separation between lens and mirror may be. So in this situation, if I find out the distance of the image from the lens, then for the lens u is equal to minus 20 centimeter and f is equal to plus 15 centimeter. So if I apply the lens formula, 1 upon v minus of 1 upon u, that is minus 20, is equal to 1 by f. So from this equation the value of v comes out to be plus 60 centimeter. Now in order the image of the point object coincides with the object itself, we have two situations. First, the image formed by the lens must lie at the pole of the mirror. So in that situation the rays get reflected and again the image formed on this point. If this is the situation, then the value of d must be equal to 60 centimeter. So option A is correct. And the second situation is the image formed by the lens must lie at the center of curvature of the concave mirror, so that the rays fall normally to the concave mirror, then it will trace its path and again the image formed on the object itself. In that case we have to add this separation, the radius of curvature, to this 60, and the radius of curvature is 30 centimeter. So the total separation d becomes 90 centimeter. So option C is also correct. So the correct answer for question number 11 are option A and C. Let's move to question number 12. In question number 12, consider the circuit shown in figure. Switch 1 is closed for a long time while switch 2 is open. At t equal to 0, positions of switches are flipped. Then we have to check the validity of given statements. So initially we have to close the switch 1 and the switch 2 is open. So when the switch 1 is closed for a long time, then this capacitor will get completely charged. At that moment the positive charge is on this plate CV0 and the negative charge is on this plate minus CV0. Now after a long time, when this switch is open and this switch is closed, then this capacitor start discharging. So at t equal to 0, this capacitor will behave like a conducting wire because it is neutral. So at that moment, the current in the circuit I is equal to Q by RC, where Q is CV0 and the value of R is 2R and the value of C is C, as this is behaving like a conducting wire. So this comes out to be V0 by 2R. So option A is correct and B is wrong. Now in option C, the energy dissipated in the resistors till steady state reach is this much. So if I calculate the common potential in a steady state, that comes out to be total charge divided by total capacitance. So this is equal to CV0 and total capacitance is C plus 3C, so 4C. So it is equal to V0 by 4. So in a steady state, if I calculate the final energy stored in the capacitor, that is equal to half into C1 plus C2 V common square. So C1 plus C2 is 4C and V common is V0 by 4 whole square. So this comes out to be 1 by 8 CV0 square. Initial energy stored in the capacitor A is half CV0 square. So if I calculate the difference, that is the heat dissipated through resistors, so it comes out to be 3 by 8 CV0 square. So option C is also correct. In option D, charge on capacitor A at a steady state is CV0 by 2, which is wrong, because in a steady state charge on capacitor A is C into V common, that is CV0 by 4. So option D is wrong. So the correct answer for question number 12 are option A and C. Let's move to question number 13. In question number 13, for the circuit shown, angular frequency omega naught is adjusted so that current I through source is in phase with applied voltage source. Then we have to check the validity of given statements. So if I draw the phasor diagram, let V0 is drawn on this axis, V0. Then the current through the capacitor will be in this direction ahead of the V0 by an angle of pi by 2, and it can be written as V0 divided by XE, so 1 divided by omega naught C. So it comes out to be V0 omega naught C. V0 omega naught C. Now the current through RL circuit, let it makes an angle theta, and it can be written as V0 divided by under root of R square plus omega naught into L whole square, so that can be written as omega naught square L square. Now it is given in the question, we have to adjust the value of omega naught so that current I through the source is in phase with voltage source. So in order that the current I is in phase with the voltage source, so the component of this current in this direction is sin theta, and that must be balanced by this. So we can write V0 into omega naught into C is equal to V0 into under root of R square plus omega naught square L square into sin theta. We can write the value of sin theta. We know that cos theta is equal to R divided by under root of R square plus omega naught square L square. So sin theta from here comes out to be omega naught L divided by under root of R square plus omega naught square L square. So if I substitute the value of sin theta, this is omega naught L divided by under root of R square plus omega naught square L square. So if I solve this equation, the value of omega naught comes out to be under root of 1 by LC minus R square by L square. So option C is correct. Now I have to find out what is the value of the current through the source. So current through the source at that moment I is V0 divided by under root of R square plus omega naught square L square component cos theta, and cos theta is r divided by under root of r square plus omega naught square L square. So that is equal to V naught into r divided by r square plus omega naught square L square. So from here we can write the value of omega naught square L square, that comes out to be L by C minus r square. So this comes out to be V naught CR divided by L. So option B is also correct. So the correct answer for question number 13 are option B and C. Let's move to question number 14. In question number 14, a radioactive nuclei X with active nuclei N at time t decays with decay constant lambda. Let R is equal to log of mod dN by dt. Suppose the experiment starts at t equal to 0 and variation of R is plotted against time as shown. Then we have to check the validity of given options. We know that minus dN by dt rate of decay is equal to lambda into n, where lambda is the decay constant and n is the number of active nuclei at time t. So if I take the mod of this is equal to dN by dt mod is equal to mod of lambda into n or lambda n. So if I take the log of this, so log of mod of dN by dt is equal to log of lambda into n, and we know that the value of n is n naught into e to the power minus lambda into t. So if I substitute this, it comes out to be n naught into e to the power minus lambda into t. So this is given as r. So I can write r is equal to log of n naught into lambda minus lambda into t. So if I compare this with the straight line equation, then the slope minus lambda is equal to minus r naught by 2 divided by t naught. So from here the value of lambda comes out to be r naught divided by 2t naught. So option A is correct and C is wrong. Now I have to check the validity of option B and D. So at t equal to 0, the number of active nuclei is n naught. So r becomes r naught. So this is equal to log n naught by lambda as t is 0. So if I take the anti-log, n naught into lambda is equal to e raised to the power r naught, or n naught, that is the number of active nuclei at t equal to 0, becomes e raised to the power r naught divided by lambda. So option B is also correct. If I substitute the value of lambda from here in this equation, this becomes equal to 2 times e raised to the power r naught t naught by r naught. So option D is also correct. So the correct answer for question number 14 are option A, B and D. Let's move to question number 15. In question number 15, a copper ring of density ρ1 and mass m1 is tied with a piece of wood of mass m2 and density ρ2. Arrangement floats completely in a liquid of density ρ3. Then we have to check the validity of given options. Since the given system is in equilibrium, so we can say that the weight of liquid displaced, that is buoyancy, is equal to the gravitational force of the given system. Or we can say that the mass of liquid displaced is equal to the mass of given system, as the arrangement is completely submerged in the given liquid. So option A is correct. So if I write the mass of liquid displaced, that is equal to mass of liquid displaced is equal to volume of liquid displaced into density. So volume m1 by ρ1, that is the volume of first copper ring, into ρ3 plus volume of wooden piece is m2 divided by ρ2 into ρ3. So option B is also correct. Now we know that this mass of liquid displaced is equal to mass of the given system. So this is equal to m1 plus m2. So if I solve this 2, then from here we will get m1 by m2 is equal to rho 1 into rho 2 minus rho 3 divided by rho 2 into rho 3 minus rho 1. So option C is also correct and D is wrong. So the correct answer for question number 15 are option A, B and C. Let's move to question number 16.